You ever look up at the night sky and you see it? A star, doing its little dance, a tiny flicker of light from who knows how far away. We've all seen it. But have you ever really stopped to wonder why it happens? Well, that's exactly what we're going to get into today.
So, here's the central puzzle, right? Stars twinkle, but planets, they don't. If you've ever spotted Mars or Jupiter in the sky, you know they shine with this really steady, solid light. Figuring out that one difference is the key to the whole thing. So what is the secret behind this amazing cosmic light show?
Now you might be thinking the answer to this celestial mystery has to be something epic, something happening millions of light years away out in deep space. But the truth, the real reason, is actually much, much closer to home. And here it is. The single biggest reason stars appear to twinkle is our own atmosphere. That's it. It's kind of a spoiler, I know, but it's true. It's not the star doing anything special. The entire show is created right here, just a few miles above our heads. Okay, so our atmosphere is the culprit. But what is it actually doing to that starlight? To get that, we need to take a closer look at this shaky, totally invisible ocean of air that we're all living under.
The main thing to get here is that the air above us isn't just one calm, still layer. No way. It's this turbulent, constantly churning mix of different pockets and layers of air, and they all have slightly different temperatures and densities. You can almost picture it like a big, invisible pot of simmering soup, and that's what starlight has to punch through to get to us.
So you've got this beam of starlight hitting all that turbulent air. And this brings us to the science, the core principle that makes the whole twinkle happen. It's all about bending light. The science behind it is a cool phenomenon called refraction, and really it's just a fancy word for the bending of light when it moves from one thing to another. In our case, that single beam of starlight is passing through all those different, constantly moving layers of air we just talked about. So just imagine this for a second. That little photon of starlight travels for maybe thousands, even millions of years in a perfectly straight line through the dead, empty vacuum of space. Then, in the very last fraction of its entire journey, it hits our atmosphere, and bam! As it zips through those turbulent layers, its path gets bent, this way and that, over and over again. To our eyes down here on the ground, the star's brightness and its exact position seem to be jumping all over the place. Our brain just interprets this chaotic little dance as a beautiful twinkle. Okay, so that totally explains why stars twinkle. But this next part, this is what solves the other half of the mystery. Why don't planets do the same thing? It all comes down to one thing: distance. Because stars are so unbelievably far away, they appear to us as just a single, tiny point of light. Our atmosphere can easily buffet that one little point of light around. But planets, they're so much closer. Now, they still look small, but through a telescope, they're big enough to look like tiny disks. This means we're actually seeing many points of light all at once. So while the atmosphere might be bending the light from the top edge of Mars down, it might be bending the light from the bottom edge up. All those tiny distortions basically just cancel each other out. And what our eyes see is the average of all that light, a steady, solid glow. No twinkle. Look, if you're still trying to wrap your head around this, don't worry. There is a perfect everyday analogy that makes this whole concept crystal clear. I want you to actually picture this. You're standing by a swimming pool, you're looking down into the water, and you see a shiny coin sitting on the bottom. As the water on the surface just gently ripples and moves, what does the coin look like? It seems to shimmer and dance around, doesn't it? Like it's wiggling. Well, in this little thought experiment, the water is our turbulent atmosphere, and that little coin is the distant star. The effect is literally the exact same thing. The light from an object is being distorted by a moving medium right before it gets to your eyes. So, if you're going to walk away with just one thing from all this, let it be this. This is the whole story in a nutshell. Stars twinkle for one simple reason. Their light gets distorted by Earth's moving atmosphere right before it reaches our eyes. It's an illusion created right here at home, not by the star itself. Pretty cool, right? So there you have it. That romantic twinkle of a star that we write poems about, it's really just starlight getting a little scrambled on its final approach. It really makes you wonder, doesn't it? Now that you know our atmosphere is a cosmic funhouse mirror, what other amazing illusions are hiding up there in plain sight?